LES Grain Expert is used to automatically identify boundaries that appear in grain specimens and to then measure the size of the grains that are determined. Identifying grain boundaries, even for the human operator, is a complex procedure because the boundaries may be indistinct and incomplete, and of course it's very tedious to try and identify those boundaries individually. What normally happens is that when this process is performed manually is that an estimation is made of the grain boundaries. But using LES Grain Expert we can identify boundaries in many types of specimens completely automatically. Even so, we also allow for the user to make manual adjustments to the results. Let's see how this can work in practice. Grain Expert, like other LES analysis modules, uses a processing sequence with a number of steps in it. The grains in different types of samples appear differently. So in this case, you can see in my gallery I'm showing you a monochrome image. There are also color images that we might want to measure the grains in, and more complex specimens where we have a second phase as well. For this example, I'm going to look at how we can identify the grains in this color image. This is an aluminium sample with polarized light. So the first step is I select the step, Identify Grain Boundaries. And the grain boundary detection works by modifying the procedure depending on the type of image that I've selected. And of course at the moment, as I came into this, I'd selected the monochrome image. So let's select a color image. So I've selected a color image, and now you can see that the boundaries here, although they're quite narrow, they've been clearly detected. If I press the Shift key to identify, you can see that the boundary has been drawn in green. In this area, the green boundary is not shown. So and also in this area, the boundary between the grains is not shown. So I need to make some simple adjustments to these two controls. So I reduce my tolerance to the noise in the image, and I reduce the sensitivity, and you can see now the grains are. And now if I zoom into a region, you can see that even on this region where the boundary was quite indistinct, two very similar levels of brown, I've still identified the boundary. So you can see that it's done a very good job of drawing those boundaries. Happens very, very quickly, and I've got many boundaries drawn. However, I deliberately showed some boundaries that were incorrect, because I can show that those can be easily removed by going to the binary image step. So I come to the editing step, and I can look at these boundaries again. And if I want to remove one of these, I simply draw a line over the boundary, and that magically removes the boundaries. So all those false boundaries that I had introduced, I've removed. I've now identified the boundaries. I can now determine how I want to present the results. And the results are presented according to a number of different types of grain standards. These standards are produced by ASTM, JIS, and the global ISO standards. So I've chosen the ASTM standard, and the method that I'm using there is going to be the planimetric method. There are other methods available as well. Planimetric is the one that is most commonly used. So this is going to measure the grains within the circle that's shown there. So I look at the result, and you can see all the grains that are measured, and when I show that as a histogram, you can see the distribution of the grain number. Drawing in the grain boundaries has been reduced to a very much faster and more straightforward task than it would be if you had to draw those boundaries in very carefully yourself.